Over the last 2 years, enterprise AI moved from a phase of adoption to a phase of massive capital allocation. Most companies locked their annual budgets before the latest models arrived, only to find themselves running multiples ahead of plan by the first quarter. The initial push came straight from the top. CEOs watched business networks, observed competitors announcing productivity gains, and mandated immediate AI integration without a clear framework for return on investment. Competitors publicly boasting about these gains forced organizations to rush their implementations, making inference a permanent line item before it was fully understood. Inference spend evolved rapidly, shifting from a small sandbox experiment into a recurring, seven-figure infrastructure expense. This scale brings a new executive mandate. Management now requires proof of exactly where AI creates leverage and which human workloads it actually replaces. Benchmarking this against internal labor is notoriously difficult. Human workflows are diffuse. Employees manage dozens of tasks while navigating daily distractions, and managers often resist reducing headcount based on partial automation. Human output is measured in completed units, a resolved ticket or an audited claim, while AI is billed in raw compute. Because these units do not speak the same language, management remains blind to marginal token utility, the actual business value generated by each additional dollar of inference. The confusion operating inside most boardrooms stems from a specific technical misconception: the assumption that AI behaves economically like traditional software. In a SaaS model, executives use software usage as a direct proxy for value. If seat licenses and daily active usage rise, the software has been successfully adopted. AI breaks this telemetry. The unit on the invoice, a token, is stable, but the amount of work that token represents changes based on the behavior of the system. This chart highlights the divergence in scaling economics. On the left, traditional software value scales linearly with seats. On the right, identical AI token spend branches unpredictably, depending on the prompt, the retrieved context, or whether an agent gets stuck in a loop. Two enterprises can receive identical API bills while running completely different operations. One converts inference into outcomes. The other pays for invisible thrash, redundant reasoning, and unnecessary tool calls that looks identical on the line item. A rising AI bill only proves that the meter is running. It does not indicate if the business is actually accomplishing work. Real-world enterprise data is fundamentally messy. When workflows hit exceptions, these fragile systems malfunction and repeatedly reset themselves in an endless loop. This friction is the first hidden driver of AI infrastructure volatility, retry tails. Because inputs are rarely perfectly formatted, agents encounter exceptions that force them into recursive loops. They repeatedly try to correct their own failures to reach a resolution. This probability tree maps out the expected cost of an agent workflow. If an agent completes a task correctly on the first pass with probability P, the expected tokens scale as the base cost divided by P. Failures in these workflows compound, a drop in completion rate from 90 to 70. In enterprise workflows, failures don't just reduce accuracy, they change the fundamental economics of the task. Compare this variable structure directly against outsourced labor. A BPO contract operates on a fixed price per completed ticket or claim, providing the business with a measurable baseline. When an AI workflow requires multiple retries, a frontier model, and human correction to succeed, the variable cost of inference can exceed the fixed cost of the outsourced labor it was supposed to replace. The second driver of cost volatility is context inflation, driven by the engineering tendency to oversupply models with information. This chart illustrates the cost mechanics for attention-heavy operations in large language models. Inference costs scale quadratically in relation to context length. Doubling the input data roughly quadruples the reasoning cost. When a system pulls 50 documents instead of 5, or an agent carries thousands of lines of stale conversation history, it exponentially multiplies the cost of reasoning through unnecessary context. The third variance driver is default model routing. When teams lack the confidence to tier their tasks, they default to massive frontier models for simple classification. They use the same model for complex reasoning that they use for basic sorting. Across millions of API calls, the difference between sending easy tasks to a smaller model versus the frontier model turns manageable engineering decisions into board-level financial crises. Surviving the token budget wars requires a specific architectural solution: the token-to-outcome attribution layer. This stack visualizes the necessary conversion layer. Enterprises must intercept inference spend and map it strictly to resolved business workflows. The middle layer is the agent trace. It records every tool called, the context retrieved, and every retry attempted. This layer forces every dollar of compute to justify itself mathematically. It reveals which parts of the agent trace were necessary to the outcome and which were merely expensive thrashing. Token-to-outcome attribution transforms AI from a technical experiment into a measurable, defensible operating model. Capturing these complex agent traces provides a permanent, durable record of how the organization actually arrives at its decisions. Traditional systems of record, like a CRM, capture that an outcome happened, a deal slipped, or a ticket closed. They rarely record the unwritten human judgment behind those events. Human decision rationale is highly perishable. It lives in Slack threads and email chains, and it disappears when employees leave or processes change. These agent traces will immortalize this human rationale. Every retrieval step, every human correction, and exception handled becomes a durable corporate asset, a context graph of organizational behavior. The team owning this attribution layer holds the power of allocation. They decide which workflows get more compute, which stay human, and which replace BPO, making them the new source of truth for where AI spend goes. It is the ultimate example of incentive-driven reality. As Charlie Munger put it, "Show me the incentive, and I will show you the outcome." The first phase of enterprise AI proved that models could do work. The next phase will decide exactly how much of that work is worth the investment.